This chapter is focusing on confidence intervals. Specifically, this particular section is going to be talking about confidence intervals for a mean. Now, what is a confidence interval? So a confidence interval is really giving us an expected range for where we can expect a mean to fall based on previous samples that have been collected. Now, we're going to be talking about a few different sections in here that all talk about confidence intervals. This particular section is going to be talking about z-intervals. Okay, now this is where you know your population standard deviation and, sorry, you have a large sample size. So that's going to be a sample size 30 or above. After this one, we'll kind of progress to our t-interval. That's our next section. So that focuses on smaller samples. And then we'll progress to talking about proportions and what that looks like. So we're going to get into what confidence intervals are, how to find them, do a lot of that heavy lifting in this first section. And you'll see a lot of commonalities from what we do in here to what we do in future sections. So we're going to be talking about a point estimate in this section. So that is a specific numerical value that is estimate for your mean. So that's your population mean. Okay, and these sample statistics are called estimators. Okay, no sample is going to be an exact replication of your population, but we do our best. So that's why these are estimators. They are not exact. So what makes something a good estimator? First off, the data is going to be unbiased. So you're getting the information from a randomly collected sample. Hopefully there's no bias in how it was collected or how you organized your sample. So that's key, that it has to be unbiased. You want it to be consistent. Okay. And you hopefully want it to approach your true parameter. So remember, a parameter is a number that describes your population. So hopefully it's approaching that value. And you want it to be relatively efficient. Okay. And really, you're looking at the smallest variance. So you don't want your data to be super spread out. You really want it to be relatively close together and hopefully surrounding that mean. So we talked about that this whole section is on confidence intervals. Okay. So what we're doing is getting an interval estimate, okay, of a parameter. So this is an interval range of values used to estimate the parameter. So for a lot of these questions, we're going to be looking at what do we think the mean is. So this confidence interval is going to give us a pretty good estimate as to where we feel that mean is in, between what two numbers could we expect it to fall. Okay. Now, the estimate that you come up with based on your sample, it may or may not fall, or sorry, may not hold the true parameter. So you can come up with this range based on your collection of information, but the actual mean may or may not belong in there. That's why when we talk about how confident we are in what we're doing, we will never say we are 100% confident. The more confident that we are, the smaller that, or the larger the ranges that we look at, but we're never 100%. So when we look here, I have an example for us. Okay, we have, hold on. Bless you, sorry. We're having this little range here. So between 26.9 and 27.7. Okay, that's our range for our estimate. The true population mean may lie between those two numbers, but this is an interval. Okay, now we are going to say we're 95% confident here. You're going to see 90 and 99 are two other ones that we commonly use. Okay, this is the probability that the interval contains the actual, in this case, population mean, but it may not be in there. It's going to be pretty close or a pretty good chance, but it's not exact all the time. Okay, so really what we're doing is coming up with critical values here. Okay, we're going to be using, we'll do it by hand. I have a formula for us to use, but eventually we'll go through and we'll use our calculator. Okay, so this is just kind of a little diagram for what it is that we're going to be doing. We're going to be using area under the curve, so what we spent a lot of time doing in chapter 5. All right, so my confidence level of an interval estimate, okay, this is looking at the probability that the interval will contain the estimate. Okay, so when we take a look at ranges of data, all right, we talk about a 90% confidence interval is a common one that we use. All right, so let's say 90% is going to be about here. Now, when you want to talk about being more confident in something else, okay, if we want to say we're 95% confident, that interval gets larger. All right, think about it when you talk about the average on a test. I may say, you know what, I'm 90% confident. I'm 90% confident that the average test score on the Chapter 5 test was somewhere in between a 70 and an 80. I'm about 90% confident the average was somewhere in there. Okay. Now to talk about, if I want to up that, you know, I might say, you know what, I'm 95% confident that the average was somewhere between, you know, actually I'll mark this down. We said between 70 and 80. Okay. You know, I'm 95% confident that it's somewhere in between 65 and 85. So notice the more confident I got, the larger that range is, better chance for the mean to fall somewhere in there. Okay. And then maybe I'll say, you know what? I am 99% confident. Okay. That the average was somewhere between a 60 and a 90. Okay. That's a lot bigger of a range of values for the mean to fall somewhere in there. So the larger or the more confident we are, the larger range or the larger the interval. So more confident means larger interval. Okay, and this is really important for you to grasp, so make sure you're writing that down. Okay. So what we're going to do is flip it to the next page. You can pause this if you need to. Okay. Now, this is just giving you a little example. We're going to be finding critical values. These are going to be numbers that are important for us to find in our z-score. I have a little formula for you on the 3rd page that you can look at as you're going through. But when you're talking about 90% confident, any percent, that's the area in between your two critical values. Remember, this is an interval, so you need a lower boundary and an upper boundary. Okay. And you could use your normal CDF function to help you find what these scores are. Okay. So 90% in the middle, you're using then to figure out, oh, what do the z-scores that correspond with that area entail? Actually, you'd be using the inverse norm function here, not normal CDF. Okay, to find what those numbers are. We'll get into that a little bit later, but what you did in the previous chapter does apply here. So what is sampling error? Okay, now, your sampling error is really the error that you're going to get anytime you take a sample. No sample is perfect, okay? But in terms of the formula, E for error, okay, is you have this z-score here. That's your critical value, and that's what you're getting based on how confident you want to be. Okay, you're multiplying that by your standard deviation divided by the square root of your sample size. Okay, so as we said here, ZC is your critical value. You have your S is your standard deviation from your sample. And you have that your N is your sample size. Now, this sampling error, as I mentioned, now this can be based on anything that you have happen with your sample. No sample is perfect. So we take into account, here's our values. We got to give a little bit of give and take for this. You never know what could happen to make a number be a little bit larger, a little bit smaller. Okay. When we look for our sampling error, okay, we're looking at our population mean, where that is, and then where in relation to that is our sample mean. Okay, is it a little bit above, a little bit below? What is that error? Okay, so here, my mean is 14.2. Okay, I'm going to take away, my bad. I'm going to start with my sample mean and subtract my population mean. And I get negative 2.2. This was my sampling error. So my sample mean was a little under 2 below, or a little over 2 below where my actual population mean was. So that was a little bit of an error there. Okay. Now you could also have that your sample error could be positive, which means that you overestimated, or your values that you got from your sample were a little bit higher than what the mean was. So this one was 1.2. Okay. But that's all right. That's possible. Now, how do you find the z-scores, those critical values that you need to use in your formula here? Okay. You're going to be looking here. I'm going to draw a quick little sketch of a curve. All right. Now you have here 1 minus your alpha. We'll talk about what alpha is a little bit more. Okay. But this is where you're seeing how confident you are. So maybe for a 95% confidence interval, that 0.95 would be there. Okay. Now, here, this is alpha over 2, alpha over 2. Your alpha, okay, alpha itself is the area in each tail. Then this 1 minus alpha, this is looking at how confident we are. Okay, that's the area in the middle. So what we're going to use, I'll give you the formula. This will be the end of this video, and then you can go on to the next one to apply it. So our mean is in the middle. Okay. Now, we're going to estimate what this mean is by starting with our sample mean. Okay, so that starts first. Now this needs to be an interval, right? So there's something we have to do to add and subtract to that sample mean to get that range of values. And that's where you're getting that standard error, or that sampling error. Okay, so you're seeing the same numbers on either side. The only thing that's different here is one of them you are adding and one of them you are subtracting. So we'll stop here and we'll move on to video 2.